Okay, so we want to start adding some more effects layers. And let's first start with the debris. So debris is going to be the big sparks here that you see blasting off of it. So it's essentially sort of part of the rigid bodies. So we have the rigid bodies, those we already did those. And then we want sort of the rigid bodies to emit like tiny debris pieces. So we're gonna do a debris simulation, and then we're gonna instance some rocks on the debris. And well, then we get this effect. So actually gonna use the shelf tools for a lot of that setup, because debris is pretty easy, but the general setup just dumps down a couple of nodes that are just like easy to use. So we're just gonna do a sort of just gonna do the shelf tools, then we're gonna go through it. I'm gonna disable a couple of things that I don't like in the debris setup. And then, well, it's a pretty simple setup, but it adds quite a lot. So let's do that. Well, first we want a geometry node here. And let's call it debris. And we want to load our rigid bodies in there. Maybe we want to rename our landscape to something like environment setup, because just makes a little bit more sense, because we did more than just our landscape in here. So let's grab our RBD there. Let's go into our debris object merge and then put this one in there and then into this object. So now we have our rigid bodies in here. All right, and let's make a dot network here, and that's going to contain our debris, and call this debris sim. Let's make that our active sim. So if you click in here, you can see all of your dot networks. Let's make that one our active one. Make sure that it's active. Then let's go up. Let's go to first frame. Let's select this and then go into the rigid bodies tab. And then control click on debris. So it's gonna think for a little bit. So you can see what this does. It makes a pop solver, and it has a whole bunch of stuff connected. And if we go up a level, oh, it didn't actually make it properly in the network that we had selected. So I guess this is one of those that always dumps its own nodes down. But let's just move that over. So let's just go in here. Let's just cut the debris sim there. Let's, I guess, paste it in there. And we need to just put the inside. So let's just dive in there. Oh, everybody needs bugging a little bit again. All right, just copy this, go into debris sim, let's paste everything in there. It's weird. So like some shelf tools will actively just put everything you want in the actively selected network, and some don't for some reason. So there's one here with the debris source. Let's just copy these nodes here, go out of there, delete it, and connect those to our object merge. And then in our source here, let's connect the out node over there. All right, so let's have a look at what our object merge does, or what our debris source does. So let's have a look here. So the impact doesn't really seem to do much because we already have impact geometry. Let's reset this simulation and see what it does. So it doesn't seem to do that much yet. So that's probably because it deletes all attributes and it keeps the name on primitive. But if we look over here, our name is on point. And it does require name attributes. So let's put name over there. So on the attributes over there. So now this source should, I think, work. Yeah, so now you can see it works. We probably don't want to emit pieces for this long. So you can just turn down the lifespan a little bit. Boom. Okay, now let's dive into our debris sim. Let's play. You can see what it does essentially is it sources the points that were just generated. So these points. So if we just dive into our debris source, it's actually quite a simple setup. But you see here it does something with the name. It scatters points on surface. Then essentially what it just does is, well, it does some wrangles. Then it transforms the scattered points to the original geometry. Then it does some extra stuff in here, just some processing. Then it outputs it as a source. You could also just scatter points on it. You would get somewhat of the same result. I could show you. Probably in our case, it doesn't really matter that much. Like if we were to just do this, see, get a very similar result to the debris source. So debris source just has some couple extra parameters, but in this case, could have just also scattered. So yeah, some stuff. So what I don't really like is this sort of clustered look. So what it does is around every point, it replicates more points, which I'm not really a big fan of. I just don't like that look. It just looks, yeah, that's a little bit fake in my opinion. So I generally just disable that. So you can see now we don't get that. And you can see, so what it does, it keeps emitting points from these points, and we don't want to keep doing that for this long. So I'm just going to put the constant activation $f below maybe frame 6 or something. So I just only want to do it on a couple of frames. Oh, $f anyway. No, that's to 7. Boom. Right, something like that. And let's merge in some collision objects, because we want them to collide with the ground, right? So let's go into our pyro to flip, because we have a dot network there that contains some collision objects. So let's copy the static solver there, let's paste it in here. Let's merge it in. Want to merge the static solver first. And then let's connect this thing. Now it needs to think for a little bit, because it's computing the collision environment. So one thing you can see happening here, which I don't like, is we have these pieces here. They're sort of bouncing. Boom, boom, boom. And I mean, I'd say that debris pieces wouldn't bounce this much. Let's go into our landscape. Let's decrease the bounce to a very low value. And let's put the bounce forward also very low. So regular bounce would be just bouncing upwards. Bounce forward is like if something hits and then gonna keep bouncing, then bounce forward would, if you lower it, it would like sort of make a smaller angle. Let's press play. So you can see now they sort of more stick to the thing. And of course, these are points. We're later gonna instance geometry on this. So these are not, like, you could also use actual emit actual rigid bodies into a simulation to have sort of more of an like a more accurate thing where they would sort of blow out and then sort of roll over the thing. But in this case, we're not really going to do that. They're just going to be super small pieces. They're going to be quite far away. So in our case, it doesn't really add much. But you could definitely do that. So I actually even have made a tool at one point called DOP instancer, which can sort of instance DOPs from points or SOPs or whatever. So something like this, for example, you could use to emit your rigid bodies. I think Houdini 18 also has something built in for it. But this would also just make it quite simple. You can get this tool on my website if you're interested in that. But yeah, let's just, for this, just do it quite simple. We don't really need any dynamics, like much dynamics on it. Just points is good enough. We might want some more points on it. I'm just gonna say maybe we can increase this number. And maybe we want to add some more force. So we could either put the amplitude up. Maybe we could say add amp equals the length of the velocity. Let's see what that does. Or just, no, not add amp, just amp. This could maybe potentially be a little bit too extreme, but let's have a look. Let's increase the scroll size. So essentially the amp will set so we'll compute the length of the velocity vector. So essentially that will be put in here. So essentially if something moves very fast, then the amplitude will be higher. If it moves slow, the amplitude will be lower. Let's have a look. I'm not sure if I'm actually liking that. I think I'm gonna remove that from it, but you can do it. You can put it in if you want. I'm just gonna do a little bit of just general noise maybe. Yeah, I guess something like that is fine. Okay, so let's go up a level and let's cache this out. Let's go in here and let's copy the name from our object here, so pop object, and let's only load that as an object. So then this thing will only load the object and not the collision objects, because it's going to be slow when you write it out. Let's delete, or let's do it at rectangle. Let's delete stuff. So if p.y is below 0, let's remove points. Because I saw some stuff drop down. So if we just look in here, you can see there's just points falling down. So we don't really need those. So now we're just going to say that if it's below 0, it's going to be removed. I think, a couple of extra points are being removed. Let's make it minus 0.5. So at least the stuff on the surface will just stick. All right. Make a file cache. Put it in. Let's call it debris sim. $170. Let's cache it out. Should be pretty fast. So we have an error here. Oh, okay, so that's probably because our rigid bodies stop after a certain frame, right? And we did time freeze them in the render node. So we kind of need to time freeze them at the last frame, because this is where this error comes in. Like if you have a file cache and you put it to error, like either to error or report error or no geometry. If you put no geometry, it would just keep running, or it would, and if you put it to error, like we have what we just experienced, it will just cancel. So we could also just have put it to no geometry, but let's just do it like this. Just I guess frame 100, the last one, and let's sketch it out now. Let's initialize simulation operators and save it out. Okay, load from disk, and we have our debris. Okay, so now all that's left to do is instance some geometry on this.